everyone. In this next video, Right Triangle Trig, Intro to Identities, we're going to continue to explore implications of right triangles and how the sides and all of those are related together. So these are called identities, and so let's continue. So before we begin, we need to talk about what is an identity. And I've written a definition here. A math identity is an equation that's true no matter what values are chosen. For instance, here I've written A equals B. And we've used the idea of an identity that A and B are the equivalent of each other. So 7 equals 7, or 7 equals 3 plus 4, right? So those are equivalent statements, and you could substitute one for the other. That equal sign is really important. That's why we don't overuse equal signs. We really mean these two things are equivalent. So for this example here, we want to know what value does x have to be so that the two sides are equivalent. And you know, we would subtract the 2 to the other side. That would be 3, right? So since x is 3, I could say that 3 plus 2 equals 5. Right? So this is an equation. This down here, 5 equals 5, this is the identity. Right? Because this is always going to be equal, no matter what. This could change. Now it won't, x has to be 3, but so we're using the implications of an identity to solve equations. That's where you've seen this before. But in trig, what we're doing is that an identity is an equation that's true no matter what values are chosen. So here, my variable is theta. It's an angle, right? So for every angle theta, the cosine of that angle is equivalent to 1 divided by the secant of that angle. And the same for this as well. The tangent of any angle theta is going to be equivalent to the value of 1 divided by cotangent theta, or, see these equal signs, right? Sine of that angle over cosine of that angle. All right, so that's what an identity is. The identity is going to be true no matter what. Not everything is an identity. Not everything is an identity. But in trig, there's some identities that we need to know, and so that's what we're going to do. So is this an identity? Now, this is a notation question. And if you'll notice, I talk a lot about notation because, remember, math is a language. And if you don't know what the notation is saying, there's no way you can unpack the problem. And so what we know from trig is that writing cosine squared x and then cosine x quantity squared are the same thing, right? I could rewrite this as cosine x quantity squared. That's what that means. Now, this does not equal cosine x squared. Do you see the difference? If you left those parentheses off, they would not be equal to each other and therefore not an identity. But because that's what it says, yes, it is an identity. Can I make one side look like the other? So the first trig identity that we're going to do is a Pythagorean identity. That's what it's called. And it's because it can be derived from the Pythagorean theorem. Now you're going to want to memorize this, but I want to show you where it comes from. All right? And it comes from the unit circle. So here's a unit circle, first quadrant only, radius is 1. That's how I know it's a unit circle. And to know that, I know that this forms a right triangle, and the Pythagorean theorem is a squared plus b squared equals c squared. Now, we're going to write down what is a on this unit circle. Well, a, right, this could be b, and those could switch, it doesn't matter. And then the hypotenuse is c. So I know that a is cosine theta, b is sine theta, and c is 1, right? So in the Pythagorean theorem, cosine squared theta plus sine squared theta equals 1. That is the identity. That is true for all values of theta. So let's give an example. We said that cosine theta is the ratio 3 to 5. Sine theta is the ratio 4 to 5. Now I want you to notice there's an equal sign between them. They equal each other. That means that one side could be substituted for the other. So we're going to use our notation that we talked about on the previous screen. Cosine theta quantity squared plus sine theta quantity squared is 1. Well, what is cosine? Cosine theta is 3/5. So cosine theta is going to get, it's not the cosine of 3/5. 3/5 is a ratio, okay? Plus the sine of theta, and you'd be surprised how we get mixed up here. So sine of theta can be replaced with 4/5, quantity squared. This is 9/25 plus 16/25, which is 25/25, which is 1. And so you can verify this identity. This is what needs to be memorized. Now, the cool thing is, once you have this one memorized, you can also derive other identities. So for instance, if I want to know what sine squared theta is, I'm just going to subtract. So I do 1 minus cosine squared theta. If I want to know what cosine squared theta is, I could replace it with 1 minus sine squared theta. So now I've derived 2 more identities, but do I need to memorize them? No. I can just use algebraic techniques to figure out what they are. So if I see this in a problem, I could replace it with cosine squared, and vice versa. All right? Now, there are 2 other Pythagorean identities, and you can either memorize them or you can learn to derive them. So the first one that I'm going to do is I'm going to divide all the way through by cosine squared theta. All the way through, every single term. Cosine squared theta, cosine squared theta. Okay? And so sine over cosine is tangent squared theta, plus cosine over cosine is 1, equals 1 over cosine, which is secant squared theta. And that's another Pythagorean identity. So you can memorize it, or you can remember how to derive it from the one you've memorized. Okay? So do the same thing with sine. Sine squared theta, just divide everything through by sine squared theta. And you're going to get sine over sine, which is 1, plus cotangent squared theta equals cosecant squared theta. The cos go together. Here are a couple of other ones that you can remember, right? So 1 over sine squared is going to be cosecant, right? So if you want the cosecant, you're going to divide by sine squared. If you want secant, you're going to divide by cosine squared. So remember, 1 over cosine is secant, and 1 over cosine squared theta is secant squared theta. Now, when we get to a later chapter in the Trig book, we're going to spend a lot more time proving identities. So this is really just an introduction, but there are a couple of things, a couple of rules that will help you with these types of problems, and then I'm going to work some examples. So basically the goal is to use a trig identity to transform one side of the equation into the other. So for instance, we ended up with some of those on earlier 1 equals 1, or sine theta equals sine theta. Right? So that would be the last statement in there. But make no mistake, the whole problem is the answer. Right? There's not just like one answer. It's a process that you do to transform one side into the other. So generally you're going to work with a more complicated side. So if you have something equal to 1, you're not going to work with the 1, you're going to work with the other side. You're only going to work with one side. And you're never going to move anything across an equal sign. Proving an identity and solving equations, 2 different things. Okay? So proving does not equal solving. All right, for solving you get x equals 3. For proving you would get x equals x. Okay? So you're trying to make one side look like the other. So here are some examples on how to prove identities, and I've written out a couple of hints there. And on the very first one, this one, if you just don't know where to begin, change everything to sine and cosine. Use the identities that you know, the reciprocals, etc. So cosine's already, so cosine theta. Secant is the reciprocal function 1 over cosine theta, right? And I'm using this side because it's more complicated than the 1. The 1, there's really a lot you could do with it, but it's hard to get it to go. All right, so this is a reciprocal function, right? And then I'm going to simplify. These are my reasons. So I've got cosine over cosine, which is 1, and 1 equals 1, and so it's proven. So I have 1 equal to the other side. All right, same deal here. I've got tangent and cosecant and secant on the other side, so I'm going to do the more complicated side, which is this one, and I'm going to use the quotient property. Tangent is sine over cosine. I'm just going to switch everything to sine and cosine and hope something cancels. Cosecant, remember, is a reciprocal function of sine. right? And then, so I've got quotient property and I've got reciprocal. I'm going to simplify, right? And so this cancels with this. So I have 1 over cosine theta, and I'm really close because I'm trying to get to secant, right? So the next step is a reciprocal. So this is going to be secant theta is equal to secant theta, and I'm done. All right? And so all of this is the solution to the problem. Okay, so on this last one, I know it looks a little more complicated, and it is. It's going to be one of the ones that we do later on in the next chapter. Okay? And so we have tangent x plus cotangent x equals secant x cosecant x. And you know what? You could use either side, and you might try the right side and then work on it for a while and not get back to it. I'm going to try the left side and just try to follow along. I'm going to write the answers as we go. So remember that we said, you know, if you don't know where to begin, maybe go ahead and switch to sine and cosine. But there are other ways to do this. There are more than one way. So sine x over cosine x, that's the quotient, right? And then cotangent is just the reciprocal, so I'm just going to flip it over. Okay? Now I have two fractions, right, with a plus between them with different denominators. So I'm going to get a common denominator. All right? My common denominator is going to be cosine x times sine x, right? And so there's a fairly simple way of doing that, and I'll probably show you that one in class. But on this fraction, right, if I add a sine x to the bottom, I have to add it to the bottom. I also have to add it to the top, because that's a form of 1, right? So this would be sine squared x over sine x cosine x. Same deal here. I would add a cosine x, form of 1. So I'm changing its form, but not its value. And so this would be cosine squared x. Okay? So I'm getting a common denominator, right? So I've used the quotient rule. Sorry, this is terrible handwriting. Quotient rule, right? Quotient property, not really a rule, property. Okay, that says pop. There we go. All right, so this right here is an identity. So I'm going to substitute an identity. And remember, it's that one we have to memorize. So sine squared x plus cosine squared x is, yes, 1. So I'm substituting. Now, at this point, once I've gotten to here, I want to go back up and see, what do I need this to look like? Well, secant is 1 over cosine times cosecant, which is 1 over sine. That's what I have. I'm almost there. So split this up. I'm going to split it up and substitute. So this is going to be secant times cosecant done. That's what we're after. We're after ones that are a little more complicated. Okay? So get ready and we'll come to class. Bring your notes and any questions that you might have from this video. See you in class.